Hey guys, I'm going to talk about what makes a perfect correlation. A perfect correlation means that there's a consistent rate of change. And the rate of change is just the slope of the line. So it doesn't matter what the rate of change is as long as it is consistent. So say we have a couple of lines or a few lines, so we could have one that goes here. We could have one that's like this. And ones like this. Now all of these have different slopes or different rates of change, but if the dots are on the line, then it doesn't matter. We have all perfect correlation. So for the purple line here, if the dots are here, here, and here, then we'll still have a perfect correlation of +1. It doesn't matter that the slope is lower than the other ones, or lower than the blue one, I mean. And for the blue, if we have the dots, say here, here, and here, we still have a consistent rate of change. It's consistently going up by the same amount. So if we go up by 1 on the x value, we go up consistently on the y value. And so for the blue line, we have a +1 for the correlation. So these have exactly the same correlation because it's positive, the positive direction, and all the dots are on the line for both of the lines. It doesn't matter that the slopes are actually different, it just means that we have the same slope throughout all the dots. It's changing at the same rate. For the green line, if we have dots here, oops, sorry, it's supposed to be on the line, here, and here, then we have a correlation of -1. The reason it's negative is because it's going in the other direction, but all three of these lines have a perfect correlation. It doesn't matter if it's positive or negative. So you might have a question like this, and you have to find the y value that makes this a perfect correlation. So what you want to do is you can draw the plot if you have graphing paper and find what the next one would be. That's one way to do it, so I'll do that way first. So you want to plot the first dot, and the first dot would go here. So this is 1, 1. The next dot would be here. This is 5, 3. So go over 5 and up 3. And then you want to draw a line and extend that line past the dot. So you want the line to go perfectly through each of these dots. And then you also need to use a ruler so it's perfectly straight. If it's not perfectly straight, this won't work. And then you want to go over to where it says x is 7. So that's here. And go up this line. And draw a dot where the 7 intersects with your line that you had drawn with a ruler. And that's right here. Let me clear that so you can see it. So where that is would be 4. It's right here. So this would be 4, would be your answer. So that's one way to do it. Another way to do it is to find the rate of change, right? So the rate of change or the slope is the difference in the y's divided by the difference in the x. So we could do it this way. So we could say the slope equals 3 minus 1. So the y's go on top. It doesn't matter which way you do it. You just have to do it consistently for the x's too. So because we did the 3 first here, we want to do the 5 first on the bottom. 5 minus 1. So then we're going to get 2 over 4. And then I'm going to simplify that to 1/2. So each time that x goes up 1, y goes up 1/2. Okay? So that is true. So now we want to figure out what the y was at the bottom, which is 4. But if you don't draw, you can do it this way too. So if we're going up from 5 to 7 by 2, then you want to multiply your 1/2 times 2, because for each time we go up by x by 1, we go up by 1/2. And if you go up by 2, then you're going to go up by 1. Okay? And so then you take that answer and add it to that y there. So plus 1, which equals 4, which is what we got there too. That's another way to do it. So this would mean that we have a perfect correlation if all the dots are on the line. Doesn't matter what the rate of change is or what the slope is, as long as all the dots are on the line. There you go.